All right, in this video, I'm going to be working multivariable calculus homework 5.2. And so this is some separation of variables examples for a differential equations class. Not really for an AP calculus class, although, I mean, like if you're in AP calculus, you could solve these, right? You're just going to, we use t instead of x and y prime instead of dy dx. Otherwise, these are still separable. And so this should be good for us, right, in our differential equations class, because we are hopefully very fluent in separation of variables coming out of AP calculus. And so we're going to start by finding the general solution to the differential equation y prime is negative t divided by y. So that means that dy dt is negative t over y. I'm going to separate variables, so that'll be multiplying by y and by dt. Okay. Then I'm going to anti-differentiate both sides, and then I'll get 1/2 y squared equals negative 1/2 t squared plus some constant. And then I'll double both sides, and I'll say that y squared equals negative t squared plus c. And then I might add t squared to both sides, and I'd say that the general solution is the set of all t squared plus y squareds equals some constant. Okay, so this is the set of all circles centered at the origin with various radii. Okay, and maybe you remember that we saw that this is, this is the type of differential equation that gives you a circular slope field. I could also say that there's, there's a geometry fact hiding in here that the radius is orthogonal to the tangent at the point of tangency on a circle. That's in there, because the radius would have slope y over t. Okay, but I think that's all I've got to say about that one. That's, okay, no, it's right under here. So let's roll that up a little bit. Let's see, all right, the particular solution to the differential equation y prime equals t to the 4 minus 1 over y to the 2 that goes through the point 0, 3. Whoops. Let's say, suppose that the particular solution is f of x and f of 0 equals 3. Okay, okay, whatever. F of 0 equals 3. All right, you can kind of see that. So that means that y to the 2 dy equals t to the 4 minus 1 dt. Okay, now I can anti-differentiate both sides. So that's 1/3 y to the 3rd equals 1/5 t to the 5th minus 1t plus some constant. So I'm going to triple both sides, and I'll get y to the 3 equals 3/5 t to the 5 minus 3t plus some new constant. And then I would take the cube root of both sides, or take both sides to the 1/3 power. However you feel. But making sure that we're taking the whole other side to the 1/3 power. That's where a lot of AP calculus students go wrong, is they just want to take the cube root of some of these, but not all of it, or something like that. Don't do that. So now I'm going to use my initial condition. I'm going to say 3 comes back when t is equal to 0. So 3 is going to be equal to 3/5 of 0 minus 3 zeros plus c to the 1/3. Okay, so I could cube both sides to solve for 3, or I could think, okay, I need to take the cube root of 27 to get 3. Either way, we're going to see that c is equal to 27. And then we can say that, f of t, our particular solution, is the cubed root of 3/5 t to the 5 minus 3t plus 27. And yeah, that's a good particular solution. Now, number 3, we're going to, I can keep that going. Find a particular solution to y prime equals e to the t plus y with y of 1 equals negative 1. All right, so the first thing we need to do is use like an algebra property that, x to the a times x to the b is x to the a plus b. Okay, so I can undo this and say, all right, well, dy dt is equal to e to the t, e to the y. So I could divide both sides by e to the y, multiply both sides by dt. And then this is negative e to the negative y equals e to the t plus c. meaning e to the negative y equals negative e to the t plus c. Right? It's minus c, but it's going to be the same thing. It's some other arbitrary constant. Then I'll take the log of both sides, and I'll say negative y is equal to the log of c minus e to the t. And then I could get rid of this negative by saying y is equal to the negative log of c minus e to the t. Okay, now, what was I going to say about this? Oh, yeah, I mean, you could say this is the log of 1 over c minus e to the t, but like at a certain point, I don't think you're any better off using log properties. Good to know them, but you're not any more right if you use them. So we're going to go over here and we're going to say y1 equals negative 1. Okay, so I'm going to have negative 1 equaling, scoot that down a little, the negative log of c minus e to the 1. Oh, goodness. All right, well, then that means that 1 is equal to the log of c minus e. 1 is equal to the log of e, so c is going to need to be 2e's, right? Because 2e minus 1e would be 1e, and I take the log of e and I get 1. All right, so I think that c is going to need to equal 2 times e. And I'm going to say, all right, well, y of t, my particular solution is going to be the negative log of 2e minus e to the t. And that'll be all for that one. All right, number 4. Find the general solution to y prime equals t times y. Okay, I've got this. I'm going to anti-differentiate both sides. I'm going to take e to both sides power. Right, because e to the 1/2 t squared plus c, I could split that apart into a product, and that would be e to the 1/2 t squared times e to the c, and e to the c is just some other arbitrary constant, so I'm just going to leave it there. The fact that it's plus minus means that c can now be negative after that, after I drop these, so I'll have y as plus or minus c e to the 1/2 t squared. And that's the general solution. Part A is saying, all right, find the particular solution that passes through the point 0 and negative 7. Okay, so negative 7 equals, well, I guess we don't really need the plus minus here, right? You can just say it's going to be positive c with allowing for the possibility that c would be a negative number. Anyway, I'm going to say that this is going to be, c times e to the 0. Okay, so that means c equals negative 7. So the particular solution would be y of t equals negative 7 e to the 1/2 t squared. Okay. And hold on, thought I had something else to say about that. In part B, we're going to look for the particular solution that passes through 0, 11, and we can see that's going to play out the same. C is going to be 11, so it's going to be y of t equals 11 e to the 1/2 t squared. I'm really not sure what I was getting at, why I put, maybe I thought that maybe I needed t minus 1 times y, because those are a little more interesting. But, I'm pretty sure y'all knew how to deal with that last year, and I'm pretty sure you still know how to deal with that, so I think you're going to be all right. We're going to find the particular solution to the differential equation y prime is sine of 4t. Okay, this is separable, but I don't see any need to, right? Like you could have dy equals sine of 4t dt and anti-differentiate both sides. So you could say, okay, if y prime depends on t only, then this is just like, here's the derivative, find the antiderivative. And so that means to me that y is going to equal negative 1/4 of cosine of 4t, right? Yeah, because it would be positive 1/4 sine of 4t times 4 for the chain rule. Yeah, that's going to be. And then we want y of pi over 4. So they say that when t is pi over 4, y is going to equal by 4. Right, well, how's that going to happen? Let's see. Okay, so now this means that y of t is going to be negative 1/4 of cosine of, 4 pi over 4 is pi. So 7/4 equals negative 1/4 of negative 1, because cosine of pi is negative 1, plus c. So it's 1/4 plus 6/4. So I think that means c needs to equal 3. So yeah, my solution is y of t equals negative 1/4 cosine of 4t plus 3. And then the last one is y prime equals 1 minus y. I feel like I've been noticing that one a lot in AP Calculus this year. I don't know, maybe I've just been paying closer attention, or it just happened to come up a few times, but y prime equals 1 minus y that happens to pass through the point 0 and 100. Okay? This one's separable. We can't separate with addition and subtraction. We have to divide over here. So this is going to be 1 over 1 minus y dy equals, well, just dt, right? And then I'm going to anti-differentiate both sides, and so I would think it would be the log of the absolute value of 1 minus y, but I need to take a second and think, because this inside has its own derivative. Even though it's linear, it's going to have a non-trivial derivative, so it's going to have that negative 1. I need to prepare for that right out there. Right? Okay. Now I think about it, negative 1 over 1 minus y times 1 for the chain rule gives me that positive 1 over 1 minus y that I'm expecting. And so then I'll anti-differentiate dt and get a t plus c. I'll get rid of the minus. Okay, take e to both sides power. Okay, and then 1 minus y equals plus or minus c e to the negative t. Yeah, this is one where it actually did not. Oh, no, it wasn't t minus up there. I did not need to adjust this with a t minus 1. I need to make it a y minus 1. That would have had this extra constant kind of hanging on out here, which I think what I was trying to get at with number 4, a and b, but I'm still not totally sure. I'm just going to keep doing some algebra here, and then, okay, now I've got it. Okay, now plus or minus multiplied by negative 1, I guess that would be minus or plus, but it's still the same thing, right? So c e to the negative t. Okay, now I'm going to go and I'm going to compute the value of c, and I'm going to say, all right, y equals 100. That's equal to 1 plus 99. So I know it has to be the plus in that plus or minus. This is a red pen. I know it's going to be the plus in the plus or minus. Letting the initial condition take me there. 1 plus c e to the, well, t is 0. Okay, so that means c needs to be 99. And then my solution is y of t equals 1 plus 99e to the negative t. Okay? And that's all the problems on this set. So thanks for